Hello everyone, and welcome to How-FixIT. In this video, I'll show you how to completely disassemble the DJI Lito X1 and reassemble it step by step. This is a full repair guide for anyone who needs to fix a crashed or damaged drone and replace internal or external parts. I'll walk you through the full teardown process, including how to remove the body shell, gimbal camera assembly, mainboard, vision sensors, arm hinge shafts, and so on. If your DJI Lito X1 has a broken arm, damaged frame, GPS or sensor error, LiDAR problem, mainboard issue, or crash damage, this guide will help you understand how the drone is built and how to replace the damaged parts correctly. I'll also include the full reassembly process, so you can put the drone back together and complete the repair properly. Before you start, make sure you have the right tools: a T5 Torx and a No. 1 Phillips screwdriver, plastic prying tools and tweezers, a hot glue gun or suitable adhesive for securing connectors during reassembly. In the video description, you will find links to the tools and replacement parts used in this repair. I also recommend using a magnetic mat to organize all screws and parts during the repair process. The DJI Lito X1 uses many small screws, and keeping each one in the correct place will make reassembly much easier. A magnetic mat also helps hold small metal parts in place and reduces the risk of losing screws or making assembly mistakes. So, let's get started. Before disassembling the drone, remove the battery and propellers. Use a T5 Torx screwdriver to remove the 4 screws securing the upper cover. Now you can begin opening the drone's top cover. Start from the rear side where the charging port is located. I recommend using a plastic spudger to create the first gap. If you use a metal tool, be very careful not to damage or crack the housing. Near the rear vent inside the drone body, there is a GPS module cable. This cable is located very close to the edge of the frame, so when removing the top cover, be careful not to push your tool too deep inside the body. Otherwise, you may accidentally damage the GPS cable. Now you can remove the upper cover. To remove the gimbal camera assembly, first peel off the black protective film. Under this film, there are 2 gimbal cables, the gimbal signal cable and the gimbal flex ribbon cable. Loosen the screw and remove the metal bracket, then disconnect the gimbal signal cable from the drone's main board. Next, remove the 3 screws securing the ESC board to the drone body. This will allow the board to lift slightly and make it easier to release the gimbal cables from the frame. The gimbal signal cable is also secured to the body with ultraviolet glue. When repairing this drone, be careful with all flex cables and with the glue around the connectors. This glue is quite strong when cured, but it can be softened with a heat gun. If you don't have a heat gun, you can use a hair dryer. For example, a Dyson styler on the hottest setting works well for softening this type of glue. If you don't have a hair dryer, I'll also show how to remove the glue carefully using basic tools. The glue can be broken away, but I still recommend heating it first to reduce the risk of damaging the cable or connector. After releasing the connector from the glue, disconnect the gimbal flex ribbon cable from the main board. The gimbal flex ribbon cable is glued deeper inside the body. Carefully remove the glue and free the cable from the frame. Now that both gimbal cables are disconnected and free, we can continue removing the gimbal from the drone body. To do this, remove the 2 screws and take off the lower cover of the drone. After removing the bottom cover, remove the 2 screws securing the downward vision sensor. Now remove the screw securing the lower gimbal mount to the frame. Carefully detach the gimbal shock absorber from the frame. Work slowly and avoid pulling on the gimbal too hard. The gimbal mount has a horizontal support bar that is part of the drone body, so the gimbal cannot be pulled straight out. To release it, slightly tilt the gimbal assembly and carefully angle it out of the frame. Use the flexibility of the plastic frame to create just enough clearance, then guide the gimbal assembly out. Do not force it. Apply only light pressure to the support bar and release the gimbal carefully. Now you can safely remove the complete gimbal camera assembly from the drone body. The gimbal is one of the most fragile parts of the drone, and after a crash it is often the first component to fail. Common problems include gimbal stuck errors, gimbal overload errors, gimbal motor failure, unstable camera movement, or no camera image. These problems can be caused by a cracked bracket, damaged motor, deformed plastic frame, shifted gimbal axis, or damaged cables. The gimbal also has fragile flex cables that can tear, disconnect, or become damaged after impact, causing camera or gimbal errors. The good news is that the gimbal camera assembly can be disassembled, and many of its individual components can be replaced separately. This can be more cost-effective than replacing the entire gimbal module. In a separate guide, I'll show how to disassemble the gimbal camera assembly and replace the cable, motor, bracket, or other internal parts. I'll add a link to that detailed gimbal repair guide in the video description. Returning to the drone body, let's remove the GPS and IMU assembly. This module combines satellite positioning with inertial measurement data used for flight orientation. First, disconnect the ribbon cable from the module. The module is held in place by rubber mounts. Use tweezers to carefully release the rubber mounts and remove the module from the frame. If your DJI Lito X1 has a weak GPS signal, failed IMU calibration, unstable hovering, or crash damage around this area, this module may need to be inspected or replaced. I've included a link to the replacement GPS and IMU module in the video description below. Keep in mind that the compass is a separate component, so compass-related errors should be diagnosed separately. Next, remove the 3 screws and take off the heatsink. There is thermal paste between the heatsink and the main board. Try not to contaminate or remove it unnecessarily. If the thermal paste is damaged or dirty, it should be replaced during reassembly. Now, disconnect all cables from the drone's main board. Remove the 2 screws securing the main board to the drone frame. On the back of the main board there is a heat dissipation adhesive sheet that holds the board in place. To remove the board, you can peel this black adhesive sheet away from the frame or heat it with a hairdryer and carefully separate the main board from the adhesive. Before lifting the board, make sure all cables are disconnected. The main board, also called the core board, is the central control board of the DJI Lito X1. It contains the main processor, image transmission components, internal storage, and gimbal control circuitry. If your drone has water damage and you need to clean the board or prevent corrosion, you may need to remove the metal shields from both sides of the board. I covered the process of restoring a drone after water damage in a separate guide. If you are dealing with water damage, I recommend checking that guide. The link is in the video description. You may need to remove or replace the main board if the drone has no power, does not boot, cannot connect to the controller, has transmission problems, shows multiple module errors, or has physical damage. Before replacing the main board, always inspect the cables, connectors, antennas, and related modules. Many problems can be caused by a damaged flex cable or a poor connection, rather than the main board itself. I've also included a link to the replacement main board in the video description below. This small board is the compass module, also called the magnetometer. It is used by the drone for heading detection. The compass module is connected by a small flex cable and fixed to the frame with glue. It may need to be replaced if the drone shows persistent compass errors, failed compass calibration, incorrect heading direction, crash damage, or corrosion after water damage. GPS and IMU issues should be diagnosed separately, because this is a separate module. Now, remove the two screws, disconnect the cable, and remove the upper vision sensor. The upper and downward vision sensors are part of the DJI Lito X1 obstacle avoidance and vision positioning system. These sensors may need to be replaced if the drone shows vision sensor errors, obstacle avoidance problems, failed calibration, unstable hovering near the ground, crash damage, corrosion, or physical damage to the sensor lens, flex cable, or connector. Before replacing a vision sensor, always check the cable connection and clean the lens. Many vision errors can be caused by dirt, fingerprints, poor connection, or damaged wiring rather than the sensor itself. Next, disconnect the two cables, then remove the two screws and take out the front LiDAR module. The front LiDAR module is part of the DJI Lito X1 sensing system. It works together with the omnidirectional vision system to improve front obstacle detection and precision. This module may need to be replaced if the drone shows LiDAR errors, front sensor errors, obstacle avoidance problems in normal flight conditions, failed calibration, crash damage, water damage, corrosion, or physical damage to the sensing glass, cable, or connector. Before replacing it, always inspect and clean the sensing glass and check the cable connection. Dirt, fingerprints, scratches, protective film, or a poor connection can cause sensor problems even when the LiDAR module itself is still working. Now, let's remove the vision interface board. This board is secured with glue and also attached to the drone frame with double-sided tape. To remove it safely, first remove the glue. Then heat the board with a hairdryer to soften the double-sided tape and carefully separate it from the drone frame. This is the vision and LiDAR interface board. It connects the front LiDAR module and the vision sensors to the main core board, and it may also provide power regulation for the sensing system. If the drone shows LiDAR errors, vision sensor errors, obstacle avoidance problems, failed sensor calibration, or if both the LiDAR and vision sensors are not detected after a crash or water damage, this board should be inspected and may need to be replaced. Before replacing it, always check the sensor glass, flex cables, and connectors. Turn the drone over, disconnect the downward vision sensor cable, and remove the sensor module. As mentioned earlier, the downward vision sensor may need to be replaced if the drone shows vision sensor errors, obstacle avoidance problems, failed calibration, crash damage, corrosion, or physical damage to the sensor lens or flex cable. Now we'll remove the infrared sensor flex cable. This cable is secured with UV glue, so carefully remove the adhesive first. The flex cable is also glued to the drone frame. You can heat it with a hairdryer to soften the adhesive and separate it more safely. Once the cable is free, carefully pull it out of the drone frame. This is the lower vision and infrared sensor flex cable. The downward vision sensor connects to this cable, and the bottom infrared sensor is built directly into the same flex assembly. If this cable is damaged, pinched, corroded, or not connected properly, the drone may show downward vision sensor errors, vision positioning problems, failed calibration, unstable hovering near the ground, or landing issues. Before replacing the sensor or main board, always inspect this flex cable and both connectors carefully. Now, I'll show you how to remove and replace the front arm hinge shaft. First, remove the 2 screws securing the arm to the shaft. After removing the 2 screws, separate the drone arm from the shaft. This gives you access to the 3 screws securing the shaft to the drone frame. Remove these 3 screws, then take out the front arm hinge shaft. The arm hinge shaft should be replaced if the arm does not fold or unfold smoothly, does not lock properly, has excessive play, sits at the wrong angle, or if the hinge was bent, cracked, or damaged after a crash. I've included a link to a replacement front arm hinge shaft for the DJI Lito X1 in the video description. Now, let's remove the rear arm hinge shaft. Remove the 2 screws securing the rear arm shaft to the drone frame. After removing the screws, press down on the shaft from the back and remove it from the frame. A link to the rear arm hinge shaft is also included in the video description. On the DJI Lito X1, each arm shaft is different for the front left, front right, rear left, and rear right arms. Make sure to install the correct hinge shaft for each side. At this stage, only the ESC board remains on the frame. The ESC board controls the propeller motors. It may need to be replaced if the drone has motor errors, ESC errors, 1 or more motors do not spin, or if the board has visible damage, corrosion, burned components, damaged connectors, or broken solder pads. The motor wires from all 4 arms are soldered directly to the ESC board, so if you need to replace a damaged arm, motor, motor wire, or the ESC board, this repair requires soldering experience because the motor wires must be desoldered and later soldered back in the correct order. At this point, the drone is fully disassembled for any repair that does not require soldering. Everything that can be removed and replaced without using a soldering iron has already been removed. From this video, you learned how to take the DJI Lito X1 apart step by step and understand how this drone is built from the inside. You also learned what each module does, what it is responsible for, and which symptoms may indicate that a part needs inspection or replacement. This can help you diagnose problems after a crash, water damage, sensor error, gimbal issue, GPS problem, vision system error, LiDAR error, mainboard failure, ESC fault, or damaged frame component. Before starting the reassembly, I recommend taking a short break. A full teardown requires a lot of attention, and the reassembly process needs the same level of focus. Give yourself some time to rest, check that all parts are organized, make sure no screws are missing, and then continue with the full reassembly process. Now let's put the DJI Lito X1 back together step by step and bring it back to fully working condition. First, install the rear arm hinge shaft back into the drone frame. Make sure you are using the correct shaft for the correct side, because on the DJI Lito X1, the front left, front right, rear left, and rear right hinge shafts are different. Insert the shaft into the frame, align it with the mounting holes, and secure it with the screws. After installation, check that the rear arm folds and unfolds smoothly. Now install the front arm hinge shaft. Place the shaft into the frame, align it correctly, and secure it with the 3 screws. Then attach the front arm to the hinge shaft and tighten the 2 screws that hold the arm in place. Check the arm movement and make sure it locks correctly in the unfolded position. Next, install the lower vision and infrared sensor flex cable. Route the cable through the drone frame exactly the same way it was installed before. Be careful not to bend, twist, or pinch the flex cable. The bottom infrared sensor is built into this cable, so make sure it sits correctly in its original position and lines up with the bottom sensing window. Now connect and install the downward vision sensor. During reassembly, some cables, connectors, and small modules need to be secured again with adhesive. For the best result, use electronics-grade RTV silicone, specifically neutral cure silicone. It stays slightly flexible after curing, helps absorb vibration, and keeps flex cables or connectors from coming loose during flight. If you don't have electronics-grade silicone, the hot glue sticks can be used as an alternative. I recommend choosing durable and weather-resistant glue so it can provide basic vibration support for connectors and cables. I left a link to the recommended glue in the description, but hot glue is less precise, sets quickly, and must be applied very carefully around small connectors and fragile flex cables. I do not recommend using regular construction silicone, especially silicone with a strong vinegar smell. This is usually acid cure silicone, and it can be unsafe around electronics because it may release corrosive vapors while curing. Now install the vision interface board. Next, install the front LiDAR module. Place it into the front of the frame and make sure the sensing glass is clean and properly aligned. Secure the LiDAR module with the screws, then connect both cables. Now install the upper vision sensor. Connect the cable and secure it with the screws. Apply a small amount of hot melt glue to secure the connectors, just like the factory did. Next, install the compass module. Secure the module with a hot melt glue. Now install the main board. Place it back onto the heat dissipation adhesive area and make sure it sits flat on the frame. Secure the board with the screws, then reconnect all cables one by one. Take your time here and check every connector carefully, because a loose flex cable can cause sensor errors, gimbal problems, or connection issues. Now, reinstall the heatsink. If the original thermal paste is still clean and evenly spread, it can be reused. You can lightly gather the paste for better contact. If it is dirty, dry, or damaged, clean it and apply fresh thermal paste. Place the heatsink back over the main board and tighten the screws evenly. Good contact between the board and heatsink is important for proper cooling. Next, install the GPS module. Place the module back into its rubber mounts and make sure it is seated correctly. Reconnect the ribbon cable, then secure it with a hot melt glue. This module is responsible for satellite positioning and flight orientation data, so it must sit securely and evenly in the frame. Now install the gimbal camera assembly. Carefully guide the gimbal into the frame at an angle because the gimbal mount has a horizontal support bar. Use the flexibility of the plastic frame to position the gimbal correctly. Once it is seated, attach the shock absorber mounts and secure the lower gimbal mount with the screw. Reconnect the gimbal signal cable and the gimbal flex ribbon cable. Make sure both cables are fully connected and secured. Additionally, secure the gimbal flex ribbon cable with a hot melt glue. secure the ESC board with 3 screws. Now reinstall the lower cover. Before closing it, make sure the latches on the bottom cover are not bent. Place the lower cover onto the frame. Make sure the cover sits evenly with no gaps, then tighten the 2 screws. Now install the upper cover. Before closing it, make sure the latches on the upper cover are not bent. Place the upper cover onto the frame, press it gently into position and secure it with the 4 screws. Now install the battery and do the first power on test. Check the gimbal movement, camera image, GPS signal, vision sensors, LiDAR, and motor status. If the app asks for calibration, complete the required calibration before the first flight. If you found this guide helpful, give us a thumbs up and subscribe for more tech tips and guides. Visit our website for more insights and do-it-yourself guides. Remember, every tech challenge is an opportunity to learn and grow. Thanks for watching How-FixIT, and we'll see you in the next one.